Hi, Mr. Sapone here, and today we're going to look at how to put numbers that are already in scientific notation back into regular or standard notation. So we have some numbers on the left and a couple of rules on the bottom, and let's take a look at these rules. When you have a positive exponent, move the decimal to the right that many places. That's pretty simple. In all of these cases, we have a positive exponent, so let's do a few of them. If we have 3 times 10 squared, we're going to assume there's a decimal point right here after the 3. That is an assumed decimal right there. So if I have the number 3 here, and I have to move that decimal point that many places, whatever this exponent is. So I have to take this decimal point and move it over 1, 2 places and put it right here. Now I have to put in the zeros. So 3 times 10 squared is actually equal to 300. And that makes sense because 10 squared is actually 10 times 10, which is 100, and if you multiplied that by 3, it would be 300. That's what scientific notation is. And this next one, 2.345 times 10 to the ninth. And the rule is when you have a positive exponent, which we do, positive 9, all you got to do is move the decimal point to the right that many places. So I got to move this decimal point 9 places to the right. So once I move it here 1, 2, 3 places, I have to move it 6 more places, and I have to put in all those zeros. So 2.345. I'm going to move it 1, 2, 3, 4, 5, 6, 7, 8, 9 places, and I got to put in all my 6 zeros. So this number right here, 2.345 times 10 to the ninth is equal to 2,345,000,000. And we can put in our commas. So that's 2,345,000,000. So that's all you have to do when going into standard notation from scientific. And again, just to do the third one, 3.03 times 10 to the eighth. All we're going to do is take this decimal point and move it over 8 places to the right. 1, 2, and I got to add in 6 more zeros. 303 and 6 zeros. 3, 4, 5, 6. That's the number. It is as simple as that, 303 million. And now let's look at the opposite case. When we have a negative exponent, rule number 2. When we have a negative exponent, which these are negative exponents, move the decimal that many places to the left. So the decimal is going to go the other way. So 2.1 times 10 to the negative 2. This decimal has to move 2 places to the left. 1, 2, which means I got to put a 0 in here now. My final answer is 0.021 because I took this 2.1 and I moved the decimal over 1, 2 places. It was originally here, and I moved it over 1, 2 places. And we have 9 times 10 to the negative fourth. Same thing, we have a negative exponent, so we are moving the decimal to the left 4 places. And this is a 9, and we assume there's a decimal here. Moving over 1, 2, 3, 4 places right there. I'm going to put in my zeros. 1, 2, 3 zeros, and of course you could put in the first 0 if you need to. Cleaning that up, 0.0009. So that's how we put numbers into standard notation, and I will do the last one just so we get a little more experience. 4.34 times 10 to the negative eighth. Again, the exponent is negative, so we are going to the left that many places. This is a small number. If there's a negative exponent, it's a small number. If there's a positive one, it's a big number. So this is going to move over 1 place, and of course I know I need 7 more, and then the decimal. So I'm going to write this as a decimal. 1, 2, 3, 4, 5, 6, 7 zeros. 4, 3, 4. So this is the same exact number. And that's how you go from scientific notation to regular or standard notation. Mr. Sapone, out.